A stone is thrown upward on another planet. We are going to be using the definition of the derivative to solve this problem that has to do with position, velocity, and possibly acceleration. We can always use the definition of a derivative to go from one to the other. So we have a stone thrown upward on another planet with an initial velocity of 12 meters per second. Its height h in meters after t seconds is modeled by this h of t function. And we have three parts. We're going to calculate the average velocity between 1 and 3 seconds. We're going to figure out when the stone hits the surface and with what velocity the stone hits the surface. And I actually put these in order from easiest to hardest prompts. So I started with average velocity on purpose because average velocity is something that should be familiar to all of us from algebra. Average velocity between 1 and 3 seconds is just asking slope. So average velocity is the slope. We're going to analyze that by doing our slope formula, normally y2 minus y1. I'm going to at least write it in function notation since we have a function here. F of b minus f of a over b minus a. We're going to do difference in y's over difference in x's, or in this case t's. And then we're going to figure out when the stone hits the surface. How do you know when the stone hits the surface? That is when its position, in this case it's called h of t, is 0 meters in the air. We want to be 0 meters up, so we're going to set the height to be 0. And then the last part, the hardest part, is to figure out with what velocity the stone will hit the surface. This is the hardest one because it's asking the velocity at an instant. The specific instant when the stone hits the surface, instantaneous velocity is the derivative. Instantaneous velocity means we're going to have to apply that definition of the derivative. So average velocity is the slope formula, so much simpler than instantaneous velocity where you actually have to take a derivative and plug in. So we're going to start with average velocity, and we want between 1 and 3 seconds. So I'm going to plug in h of 3 minus h of 1 over 3 minus 1. So I'm going to grab my calculator and find these y values by plugging into this function over here. I'm going to grab my calculator. I'm going to do 12 times 3 minus 2.56 times 3 squared and see what that y value is. So we are up to 12.96 meters. That's my height at 3 seconds. Minus my height at 1 second. I'm just going to replace those t's with 1s. After 1 second, the stone is up 9.44 meters. Over in the denominator, 3 minus 1 second is going to be a 2-second difference. So we were up 12.96 meters minus 9.44 meters in the height, which is a difference of 3.52 meters in 2 seconds. So our average velocity over that time period is 1.76 meters per second. So we got a positive average velocity on the interval from 1 to 3, which indicates that the stone is going up by 1.76 meters per second. If you get a negative average velocity, negative slope means it would be going down. But so far the stone is thrown up, and between 1 and 3 seconds, on average, the velocity is increasing by 1.76 meters per second. The height is going up. So when will the stone hit the surface? We want to figure out when the height would be 0 for the next part. So I'm going to set the height to be 0 in the original equation. We want the position to be 0. We have 0 equals 12t minus 2.56t squared. And this is one where we have to solve a quadratic. We can solve by factoring this. I could try to pull out a big greatest common factor, see what goes into 12 and 2.56, but I'm just going to go with what I see as an obvious factor that I can pull out. I'm going to pull out a t from both of these. T times 12 would give me 12t, and t times negative 2.56t t would give me negative 2.56 t squared. There are other ways to factor this, but I just like to pull out what I know I can right away without having to use my calculator to see what numbers go into both. So two things can only multiply to be 0 as long as at least one factor is 0. That first factor is nice and quick. T would have to be 0. The second factor, I might have to do a little bit of work to figure out what would make 12 minus 2.56 t equals 0. And I'm going to solve this linear equation by adding the 2.56 t over, just to get t's on one side and constants on the other. I could also subtract 12. It would give me the same type of result, but I like to work with positive numbers, so I'm going to add the 2.56 t over. And I'm closer to getting t by itself. My last step is to just divide both sides by 2.56. So I need to grab my calculator and do 12 divided by 2.56 to find the other t value to be 4.6875. Now I just need my units on this, my two solutions where t equals 0, which I might copy over here. At 0 seconds, the stone is hit on the surface, and also almost 5 seconds later, 4.5 seconds, 4.6875 seconds, we are back to the surface. Which makes my first answer make sense, because between 1 and 3 seconds, it looked like the stone was still going up at a rate of 1.76 meters per second. So it was going up between 1 and 3 seconds, but then at 4.6875 seconds, it has returned back down to the surface.